the kind intro, Jacob. So what I'm going to talk about today is how to use some deeper type of reasoning techniques in decision context and what some of the advantages that brings, and talk about a new use case that we've developed recently. Previously at DecisionCAMP, I've presented use cases on financial regulatory compliance and on personalized tutoring in science. Okay, so just a little bit about me. I've turned entrepreneur the last 3 years, and so I'll be presenting technology that is based on a standard knowledge representation abstraction called RULOG, which is in process of being standardized through RuleML, working with RIF and W3 and OASIS. Previously, I was a program manager for Paul Allen at the predecessor of the Allen Institute for AI, and that's where the theory and the algorithms and the UI approach for RULOG were developed. And before that, I was at MIT and IBM Research and Stanford. Okay, so what I'm going to do is start with a bit of intro about analytics for knowledge that is fairly complex in form, with a lot of dependencies and chaining and reasoning. Often knowledge that starts out life in natural language. So in some of those previous case studies, we looked at legal financial regs and associated policies, scientific textbook, for example, in biology or physics. Then I'll present a demo with case study in the area of healthcare treatment guidance and how to personalize that and what some of the challenges and some of the advantages of this technology are there. And one of the interesting things that this technology is capable of, and I'll show you, is generating interactively navigable, fully detailed explanations that are understandable to non-technical users. Then I won't have a ton of time today, but I'll do a quick tour of the underlying technology aspects, focusing on a couple of key concepts. One is the idea of human-machine logic. People talk about human-machine interfaces or human-machine other things. And the idea here is that there's one logical system, but you can view things both in English syntax, pure logic syntax, and also in terms of hybrids. And in fact, the KB development methodology that we're using in this case study uses a hybrid, which is a new mechanism, a relatively recently developed mechanism in our technology. And the second key concept is that of virtualizing, which is kind of like what Larry Goldberg talked about with the adapters of diverse knowledge sources via what we call connectors. Okay, so today there's a lot of info in books, sometimes diagrams, that's pretty complex in form, but commonly used. So policies, legal info, such as regulations and contracts, mappings among terminologies. If you look at most of the content of dictionaries and thesauri, it's all about relating words and phrases to other words and phrases, and that mapping or relating information itself is pretty complex. It takes the form of English sentences or something close to that. Also, when reasoning about causal pathways, which is very important in science and description of processes generally. Those are examples where the knowledge is fairly complex and it comes up pretty often, and using just a conjunction of first-order conditions ain't going to cut it. That's not going to work. And decades of work in artificial intelligence, knowledge representation available to press that point home. So existing non-semantic technologies for this kind of knowledge, when combined often with scads of simpler type of data, tend to be shallow, siloed, costly and slow in terms of development, patchily automated. Lots of aspects end up being done manually, opaque in the sense of not very explainable what's going on. And AI based on machine learning and neural nets is all the rage today for knowledge that people suck at articulating, like how to drive or recognize a face. okay? But for information that people can articulate, which is sitting on these shelves of books or whatever, we want to be able to articulate that and to trust the system. It's got to be able to articulate. To get the system right, to be debuggable, to be developable at all, it has to be explainable. Inaccuracy is often a result of all these other problems, and end users are not empowered to modify is another implication. Now, so what are these non-semantic technologies? You know, who are the inadequate ones here? Conventional programming languages, production and event condition action rules, whose basic DNA dates to approximately 1980, and Prolog, which dates back roughly to that era as well. Okay, so we've heard a lot of great discussion here already at the conference about, you know, both in DecisionCAMP and in RuleML about some of the advantages of taking a semantic approach. In other words, modeling, you know, the model is the executable, as Bruce was talking about. For example, in decision tables based on DMN, that's what I would call a good first step on taking a semantic approach. And there are a number of pretty important benefits here, which I've listed here, which I think everybody's pretty familiar with. I just want to introduce the terminology here, subject matter experts. Okay, now, a next step here is by getting deeper on the reasoning using our Ergo technology based on RuleLog. One's able to support many-step inferencing, model complex sentences with high fidelity, using the high expressiveness such as higher order syntax, existentials, and quantifiers, map to and from natural language, map between ontologies or terminologies and schemas, and be able to manage exceptions in a principled manner using defeasibility. And one is also able to provide explanations that are more detailed, more understandable, more uniform, and have greater scope of automation overall because more of the aspects of what you want to automate are actually capturable via knowledge in the system that can then be reasoned with. And that extends the benefits of the semantic approach. Now, what is RuleLog? RuleLog, just very briefly, for those who don't know, is an approach to semantic rules and ontologies that has been developed in a series of steps over the last decade or two. It's very flexibly expressive. The querying is polynomial time and extends database logic rather than classical logic. All right, next let's talk about the case study and its domain. So healthcare, an important aspect is providing guidance for treatment used by delivery staff, but also by the patients themselves, also used during quality oversight function within healthcare delivery institutions, which is very important, gotten a lot more focus in recent years, and also by insurers. There, you could think of them as doing oversight. You could think of them as making decisions. They approve or disapprove treatments ahead of time often. And the guidance takes essentially the form of policies. Now, in the medical world, these are often called protocols. Portions are often based closely on clinical studies. And the top 100, most large delivery institutions, have it written out and handy to their staff, for example, at leading-edge places like Kaiser or Mayo or things like that, places like that. Okay, so what kind of knowledge is involved here? You have the patient characteristics, their history, their symptoms, diseases, diagnosis, etc., their intended effects, side effects of the treatments, their drug and non-drug treatments, their test results. There's interactions between the treatments in terms of how that may produce these side effects, increase risks, or aggravate conditions and with different severities. A big challenge is personalization. So most patients have multiple medical problems, and especially the ones where most of the costs in the medical system have multiple problems. However, the protocols that are developed based on clinical studies and the policies and the documentation, it's really for one disease at a time, one treatment at a time, right? Because otherwise the complexity is overwhelming. So what this poses is you have this compositional or potentially combinatoric aspect of the different treatments, the different characteristics of the patient associated with the multiple conditions. Now, so you have requirements that are challenging to meet in terms of correctness and competence to maximize benefit, minimize harm, avoid potential errors, which is a big problem in medical, and to minimize costs as well. And so there's verifiability around that, but also explainability is crucial because the staff get educated as they do stuff. You want to empower them, including non-doctor staff. You want patients to be able to learn, to understand, to trust. They are the ones consenting often to have a procedure, a test, a treatment, or whatever. They have to be informed of these risks and upsides and downsides and so on. So there's a lot of analytics required here, not just straight automation of decision-making and decision support. And plus, to get these systems right, as I mentioned before, explainability is huge. Okay, so let's consider one particular treatment scenario to make this concrete. An intern is busy, encounters an elderly woman in a rehab facility, and she's complaining of knee pain. She says, "Oh, I've got chronic knee pain." What treatment should be given or not given, and why? And her EHR records show that she's currently taking Coumadin, which is a blood thinner, to treat the pre-existing condition that she also has of atrial fibrillation, which increases the risk of blood clot and stroke. So what we want here for the system is to give alerts, give answer, not just answer the questions, but also do things like give alerts and educate the staff and the patients as they go. All right, so let's take a look at it. Let's jump into the demo here. Here's a rule base. You see that the statements here in this kind of hybrid of logic and natural language syntax. I'll come back to that later and cover that in more detail. So we load it, and we can go to a little query window, enter a query. Like one of the analytic queries here might be question mark here prefixes a logical variable. So it says, this is essentially saying what drug is used to treat the particular disease, chronic knee pain, and that a brand name for the drug is, another variable name here called branded. All right? So this is just to give you a feeling for what kind of capabilities we can do in the system. So we enter the query. It runs. It produces answers. Just increase. Okay, so we see, there are several drugs available that treat chronic knee pain. And so we see the generic name of the drug on the left, the branded name of the drug on the right. All right? So you're probably familiar with some of these drugs, like Tylenol, Advil, and also stronger stuff, including opiates like Vicodin, OxyContin, good old aspirin, etc. Right? So another query that we might enter here is, and I actually have this in a history here available, so I just popped up with an arrow key, is what drugs are contraindicated medications for this particular patient, for the elderly lady in the rehab complaining about knee pain who has other problems. All right, so we can ask that as a question. We can ask, there's several that she shouldn't take, and this actually intersects with that previous list. All right, so if I go back to the other question, and I look at the answers, I can drill down on one of the answers. So any answer, a full explanation is available. So what it did is it computed an explanation. Let's make that bigger so we can take a look here. We see ibuprofen is used to treat the particular disease, and its brand name is, say, Motrin. Now, why is it used to treat that particular disease? Oh, it's in the non-selective non-steroidal anti-inflammatory disease class of drugs. NSAID is familiar terminology for medical staff, even many patients. And that class of drugs is used to treat inflammatory disease, and chronic knee pain is a subclass of inflammatory disease. So that's why ibuprofen is something that is plausible or suggested. It's used to treat this disease. All right. So now we can, likewise, we could click on another answer. We can click on acetaminophen and look at its explanation. So we see, okay, it's used to treat chronic knee pain. Why? Because it's in the analgesic class of drugs, and that's used to treat pain, and chronic knee pain is a subclass of pain, as well as being a subclass of inflammatory disease. Okay? So we can put all this together. And we can likewise look at an explanation for why were some of these drugs contraindicated. So, for example, let's take a look at ibuprofen. Why is that a contraindicated medication for this particular lady, patient 4? Oh, it aggravates the risk of bleeding, and it interacts with warfarin. Warfarin is the generic name of Coumadin. Why does it interact with warfarin? To increase the risk of bleeding. They both increase the risk of bleeding. Warfarin is an existing med, and it's being proposed that the patient take ibuprofen as a new medication. That's actually in the EHR already, that this is a proposed medication that they are considering. Let's say. Or could it be real time in the system? A doctor enters it. Oh, what about ibuprofen? All right. So in practice, a lot of times staff would know, ibuprofen interacts, but maybe they forgot, or it's the patient. All right. So this underlying capability can be used in a lot of ways in terms of actual UI or business process type sequences in clinical settings. The key here is the ability to support the reasoning. Okay, so we can put all this together. We could have a kind of a higher level overall query. A drug is safely recommended. What drug is safely recommended as a new medication to treat which medical condition for patient 4? And we can run this and get an answer that there's a bunch of meds that are available to treat chronic knee pain that are safe. And we might then amend the query and say, and it's not an opiate. So what you want to do is empower users, both the staff and the patients, to do these things. And again, we can look at the explanations, and basically this is because it's used to treat it, and it's not contraindicated. All right, so hopefully this gives you some feeling for the capabilities in the system. I'm now going to bounce back to the main slide thread and get into a little bit how the underlying technology works here, or what are the capabilities there as well. As we saw, this is a system that's doing knowledge representation reasoning. We have these assertions, these queries, they use the same language. It's kind of a super-duper database system is one way to think about it. It combines in some natural language processing, the explanations. Also, not shown in that example there, is that the underlying data can be pulled from systems of a variety of types. So it could be relational database through SQL, graph database through Sparkle and RDF, also pull in OWL, spreadsheets via CSV, more generally delimiter-separated variables, XML, JSON, Okay, and do these kinds of functions here, including to actively generate monitors and alerts when new info arrives. So the same system is able to have standing queries and do that too. So it's really a mixed direction system that can do both backward and forward reasoning, and for performance optimization, it stores a lot of its intermediate conclusions work. It's primarily an in-memory technique. So the architecture, there's APIs through Java Web Services C that can go out to these other types of info, gets pulled into the reasoner, combined with knowledge that's, say, natively authored in or specified as RULOG in Ergo. There's an integrated development environment for developing those knowledge bases that has tools such as the syntax checking editor that we just saw the knowledge base sitting in, and also the explanation and some other tool, the query window, some other tools. And okay, so that's just kind of briefly about the system architecture. Ergo, the system from Coherent, is the most complete and optimized implementation available of RULOG, but there are other ones available. There's an open source subset also available that Coherent helps to maintain called Ergo Lite, also known as Flora 2, that you may have heard of. There's a list of some of the different expressive features, and it has these templates that aid this hybrid style of the natural language and are used not only in the authoring of knowledge, but also automatically in the explanation generation. So overall, under the covers, there's lots and lots of pretty sophisticated algorithms and data structures doing transformation, dependency-aware updating, uses a C kernel of a virtual machine. There's performance monitoring, analysis, pausing. This technology stack has been built up for well over 10 years, largely in open source, but with several aspects as commercial extensions more recently. And so let me talk about a couple of key concepts here. One is that of human-machine or humagic knowledge. So a natural language syntax sentence can have one or more logic syntax sentences associated with it, say that encode it or specify metadata about it, such as its provenance, where it came from in terms of source, who authored it when, or what other system it came out of, that sits where, and maybe timestamps are often very important with that, of course. Maybe quality info as far as how vetted that information is. Logic syntax sentence may have one or more natural language syntax sentences associated with it that were its source or that result from doing text generation on it. And there's this ability to hybridize, as we saw. And so part of the reason why this is doable much more easily and capably than in previous technologies is that the high-power expressiveness of RULOG facilitates much closer matches, a higher level of conceptual abstraction. And in particular, technically, any English phrase or natural language phrase, if you want, can be represented as a single logical term in RULOG, and compose those out of logical symbols that are just words. So words themselves can be used very flexibly as logical symbols. So, for example, here's from another domain or another case study on financial regulatory compliance. We have, say, some logical condition that might appear in either the then part of a rule or the if part of a rule, called head and body, respectively, in RULOG. And we have question mark prefixing the logical variables, proposed transaction ID by bank with affiliate of a certain amount of dollars. Dollars is real money dollars here, is a Reg W covered transaction. It's covered by a particular regulation. And then there's a template that takes something that is unifiable with that and maps it to a purely logic syntax expression. Here, an atomic expression, you see there's a lot of nesting of parentheses. We're using words and so on. So actually, where's the predicate? Where's the arguments and so on? It's not, doesn't look quite first order, but actually looks a lot like the parsing structure of a natural language parse that's associated with a sentence in English that corresponds to something close to what we're seeing. So it's an interesting change of style in knowledge representation, and it becomes very self-documenting. It becomes much more natural, actually, than working with these long camel-cased or underscore separated types of stuff in first-order systems. And it's much more composable and reusable than those as you are dealing with complex knowledge. So almost any natural language sentence can be represented as a logical sentence with this approach, including with logical quantifiers. So, for example, here, each large company has some talented CEO. Each means a for all. Some means that there exists. And that can be represented using the logical formula here, that is directly Ergo executable syntax that we're looking at the bottom. Okay, so back to the knowledge base that we were running earlier. So we see that there's different kinds of knowledge, like about It could be ontological, like branded or generic drugs or subclass of drug, or disease and symptom or subclasses of medical condition. It could be specific facts about specific drugs and drug classes. And there's knowledge about mappings of names, like, brand name for this generic drug, is that brand name? Knowledge about disease and disease classes. So this is all kind of ontological info that we were just seeing, but it's written in a pretty self-documenting way that people can read and understand, or also author if they're business users, or they could do something very close to it. And then there are treatment guidelines, like certain classes of drugs are used to treat certain conditions. Then there are rules about what about treatment guidelines, about contraindication. These start to get more complex. You have, more conditions and ands and ors in them. You can have about vulnerability, aggravation of risk, drug interactions, when a drug is safely recommended, defeasibility, having override exception cases. It's not safe if it's contraindicated, or it's not safe for a chronic condition. If it's an opiate, because people get addicted and then they run into problems. And then you have patient facts that say it could be pulled out of an EHR database in a clinical information setting. Okay, so just to give you some feel for what that looks like. All right, so second interesting concept, kind of relates to pulling in that data, is that of virtual rule log. So this rule log is very expressive, and what it means is it can be kind of the universal solvent, the lingua franca, for orchestrating and integrating information of a variety of types from different systems. So pretty much any type of structured or textual type of information in enterprise settings. And so we have the concept of federation connectors, which import and query either statically or dynamically, and associated with that import or querying, do translation, including syntax conversion. But the semantics of the structured info in those other systems can be well represented in RuLog, including the ontologies and the mappings between ontologies or terminologies. So as I mentioned before, there are a lot of different types, and I think one thing that's interesting for the future, is one can represent probabilistic information. Basically, you get that for free as a feature once you have the other features in RuLog. So, for example, I can have a content sentence and then a lower bound probability, an upper bound probability, a confidence level, like 0.01 level of confidence associated with that range of probability bounds, and say statistical procedure or other kinds of provenance info associated with it, represent that in a Ergo sentence, pull info from multiple machine learning systems results, combine that with other non-machine learning info. You can send such information back to machine learning systems, send queries to them, feed them derived data. So I have a paper and talk at an upcoming conference on neurosymbolic workshop on combining KR and machine learning methods. We have tools for importing, for example, RDF and other kinds of information into Ergo that support a variety of formats such as JSON LD or Turtle and triples and quads, as well as RDF XML. And so, as I said, you can pretty much pull any type of pretty much any type of information, including data that sits behind legacy apps or middleware interfaces or behind REST interfaces, comes from probabilistic engines, other business rules, technology, DMN, of course, would fall in that category as well. Okay, so a few other features. I just want to mention our in the tutorial that we gave at RuleML a couple days ago, or 3 days ago, no, 2 days ago, sorry. Michael Kiefer presented some of the latest, greatest in Ergo and the capabilities for advanced knowledge base debugging. We have some capabilities already in the system for doing evidential reasoning, combining probabilistic information that comes from multiple sources, and some of the longer term directions that we are pursuing that are already under development include using natural language parsing augmented with some additional stuff to handle the quantifiers aspect of the semantics of natural language, so as to do deep semantic natural language interpretation, which I think is very exciting generally for AI and IT, and to optimize restricted cases of probabilistic. Okay, so as I mentioned earlier, we've done some other case studies. It's just a list of them. And some of the, so e-commerce was another one. And some of the lessons learned include benefits in terms of agility, which I thought was very interesting, that Bruce talked about how agility is something that customers really, really want. And some of the other advantages that I talked about earlier. Thanks very much. Yeah, go ahead.
Is there a